Hi everyone, in this video we are going to solve a problem. The problem name is minimum time to collect all the apples in a tree. And the question number is 1443. Alright, so let's see this problem, what this problem say. Given an undirected tree consisting of n vertices numbered from 0 to n minus 1. Alright, so we are given within a tree and that tree will have n vertices and the number of vertices will be 0 to n minus 1. That is clear, right? Now which has some apples in their vertices. So some of the vertices have apples and some of the vertices don't have apple, right? You spend 1 second to walk over the edges of tree. Now moving from this edge to this edge or any other edges from one edge to another edge, we need 1 second. Alright. So we need 1 second to move from one edge to another edge. Now return the minimum time in second you have to spend to collect all the apples in the tree, starting at vertex 0 and coming back to this vertices. Now this is that we are starting from this vertices, 0 vertices means root vertices, and we have to collect all the apples. You can see guys, the red vertex is nothing but an have an apple. So this 2 has apple, this 4 has apple, this 5 has apple. So we have to collect all these apples and from this particular position and come back to this position. So how we can do this? You can see here what we are doing. Here we are moving from 0 to 1 and then 1 to 4. We collected this 4 apple. We are coming back to 1. Then I'm going to move to 5 because it has apple, collected apple, then coming back to this one, then going to 0, then going to 2, collected apple, coming back to 0. So this is how I can collect an apple. I collected all the apple. Don't need to move to 3 and 6 because they don't have an apple. But in this case, we have to move to 1 because the child of 1 has an apple. I hope you are getting it. So we are moving to 1 because we know that 4 will have an apple, 5 will also have an apple. And how we come to know that this 4 and 5 will have apple? Here you can see that in this line they told additionally there is a boolean array has apple where has apple of I is true means vertices of I has an apple, otherwise it does not have any apple. So we are given with an array as well. You can see has apple. This will tell us that on what index we have an apple. Here you can see this is 2 vertices, that means 2 index has an apple. So we have 2 index true, otherwise 1 and 0 index we have false. So now I hope you understood this problem. Now let's quickly move to the logic part and see how we can solve this problem. So here guys, I'm going to take the second example and I'm going to write logic. We are going to discuss about logic. Alright. Now guys, how this second example going to work? See guys, it has a 7 vertices, fine. And edge is the same as the earlier example. And has apple here they have given second index and 5 index only true. Means second and 5 vertices only have an apple. I hope it is clear, right? Now guys, see how we can solve this. First of all, guys, we need to make an adjacent list. If you don't know what adjacent list, then let me tell you. Adjacent list tell us that how many nodes we can traverse from that particular node. So here in adjacent list, let's say this is an adjacent list. In that we have index 0. In that index we can say that in that index 0, we can move to 1 and 2. So we can write 1 comma 2. Fine. Okay, in first index we can say 1. From 1 we can move to 0. We can move to 4. We can move to 5. Remember this is undirected tree. So from one index we can move to 0 and 4 and 5, right? And you can see in second index also we can say we can move to 0, 3 and 6. So 0, 3 and 6 shown up to all the index. Here you can see we have 7. So we have to make an adjacent list of 7 nodes. Alright guys, so with this adjacent list we can solve this particular example and let's discuss is how we can solve it. So here what I'm going to do, I'm going to say I'm going to start from 0 as they told we have to start our journey from 0. So we are going to start from 0. Let's say we started from 0 node. Then guys, you can see that in 0 index we can move to 1 and 2, right? This adjacent list telling us that we can move 1 and 2. Alright. So we have to make one more variable that let me take a boolean array or you can take a set, but here I'm going to take array. But in implementation I'm going to use a set. It will not create a confusion because both the thing work same. So what I'm going to do, I'm going to initially put false. Alright. So we have 7. So I'm going to take false. Fine. So we have taken a false on every indexes. Fine. From 0, I'm going to start my journey. So what I'm going to say, from moving ahead, make this value true. From 0 index is going to be true. That means we have already traversed 0. Fine. Now guys, we are moving to 1. We can move to 1 and 2, right? This adjacent is telling us, okay. So we are going to move 1. Fine. Now we have 1 index, okay. So guys, from 1 where we can move to 0, we can move to 4, we can move to 5, right? So but before moving ahead, I have to make this true, this particular index. So I'm going to say 1 is going to be true now. That means I don't need to visit again. Now once moving to 0, you can see that I have already make it true. That means I can't move to 0 again. So this is not going to be happen. But I can move to 4 and 5, right? So let's say I move to 4, okay. But this 4 has an adjacent list nothing but 1, right? Because we can see that from 4 we can move to 1 and no one elsewhere. So what I can say, it will move to only 1, but 1 has already been true. So it will not gonna move anywhere. And here what we are going to do, we are going to return. So what we will return, we will say first of all whether this has an apple. No, this doesn't have an apple. But any of child they have an apple. No, they also don't have any apple. So it is going to return 0. I know guys, it might be confusing, but believe me, once you draw this tree, definitely you will have a better idea how this is working, why I'm returning 0. But let's try to make this tree first. So from 4, what we are going to do? We are going to return 0 because it doesn't have any apple, and also their child not have any apple. Fine. So it will say that from 4 to 1, I'm going to return 0. That means I don't have any apple. Fine. Now this one also can move to 5 as well. You can see in adjacent list. So we are going to move 5. Okay. And before moving ahead, we have already make it true, right? Now we can say, does 5 have any apple? Yes, 5 has apple. So it is going to return 2. Not 1. It is going to return 1 plus 1, that is 2. Why? 1 for coming 1 to 5 and 1 for moving 5 to 1 backward. Why? Because we have seen that we have to come 0 position again. Not we have to collect all the apple. We have to, after collecting, we have to come to that initial position. So 1 for coming. So let me take a different color. So 1 for coming and 1 for going. So this is going to take 2. So it is going to return 5 to 1. That is 2 value. Fine. That is clear, right? Now guys, you can notice that from one vertex I need just 2 step or 2 seconds to collect all the apples from the all the child. So I need just 2 step to collect all the apples. So how many second I'm going to return to 0? I will return 4. Why? You guys can see that one not have any apple, but one child has an apple. You can see, one we don't have any apple, but its child, that is 5, it has apple. So I need to traverse this path as well. So I will say coming from 0 to 1 and outgoing from 1 to 0 is also gonna take a second. So we can say 2 plus 2 is going to be 4. So this 0 will have 4 from the left side. I hope you understood this. In this example, you can see 1 to 5, it is one step. 5 to 1, it is one step. That means two step. But 1 to 0 is also one step. 0 to 1 is also one step. And the reason is, guys, one doesn't have any apple, but one child has an apple. So we have to take that particular path as well to move that particular child. So we can take only path when either the child has an apple or that particular node has an apple. Otherwise, we don't take that particular path. Fine. So we can say from the left side we have 4, but from the right side, let's take a 2. We can move to 2. You can see in adjacent list, we can move to 2 as well from 0. So from 2, what we can do? We can say that, guys, from before moving ahead, we are going to make this true. So second index is going to become true. Now guys, from 2 we can move to 3 and we can move to 6, right? I'm going to do little fast because we have already traversed the left side. And in 3, what we have? We don't have any vertices and it does not have any apple as well. So it is going to return 0. So we don't need to traverse this path. So we are going to say just return 0. And in this 6 also doesn't have any apple or their child doesn't have any apple. So this is also going to return 0. So from 2 we can say we need just 0 step to move all the childs because they doesn't have any apple. Now does 2 has an apple? Yes. 2 has an apple. So you guys can see that 2 has red color. That means it has an apple. And we can check it by passing in our has an apple array. You can see second index we have true. So this 2 say I have an apple. So I'm going to take 2 seconds. And one for coming 0 to 2 and one for going back from 2 to 0, right? So it's going to take 2 seconds and it's going to give 2 seconds to 0, right? 0 says that I need 2 seconds to traverse right side and I need 4 seconds to travel left side. So total second it need 4 plus 2, that is nothing but 6. I hope you understood this, how I got this 6 value. If still you have any kind of doubt, don't worry. We will see the code part and see how we can implement this one. And there we will understand how this recursion, or we can say depth first search, is going to work. So here guys, first of all, what we are going to do, we are going to create an adjacent list. So how we can do this? So first of all, let's create empty adjacent list. So I'm going to say adjacent list is going to be nothing but 4 underscore in range of n, means we need a adjacent list for every node, for every vertices. So here what I'm going to do, I'm going to create an empty list for now. So I created an empty adjacent list for every node. After that, what I'm going to do, I'm going to traverse these edges for a comma b in edges. Alright, so here it says that we can have a path from a to b, right? So we can say we have a path a to b, so we can say adjacent list of a have a path of b, right? So we can say append b. And it is also the case that b from b also we can go to a. So we can say adjacent list of, let me write adjacent list of b dot append a. That means we can say that from b also we can go to a. Alright. Now guys, what we are going to do? We are going to use a function. That function name is going to be defined. I'm going to give a function name solve. Okay. Or we can say, what is the question series? So we can say apples. So let's give it a name get apple. Fine. Okay. Now what I'm going to do? Now I'm going to take the value where we are currently standing. That is going to be 0. So this will be defined by node. After that, one I told you I'm going to take a set. You can take an array as well. Both are going to work same. Fine. Now what we are going to do? Before moving ahead, we have to make that particular array true, or we can say we have to add our node in a set, right? Is visited dot add node. Right, now we have added that particular node so that we can't come this particular node again. Okay, now what we are going to do, we are going to traverse on every node, right? In the example you have seen that from 0 we can move to 1 and 2, right? And from similarly from 1 we can move to 0 to 4 and 5. So same we are going to do. We can move traverse every particular possibility. So we can say for vertices in adjacent list of node, that means all the vertices which we can have from this particular node, we can move to that particular direction. So move all the direction, but before that we have to check also whether this vertices has already been explored. So we can say if vertices in is visited set, that means it's already been explored, so we don't want to explore it again, so we'll say don't do anything, continue it. And this line we can do right directly. We can say if vertex is not in invisible, then you can do your tasks. So what I'm going to do, I'm going to call this function again, get apple. And here now my node is nothing but vertices. All right, and is visited going to be remain same. So I can say is visited. Now guys, what we are going to do, we are going to add the every second which are coming from this particular path. So we can say I'm going to define a second. So I'm going to say second, or we can say total second, which is going to be initially 0. But after that, here we will add all the second. Whether it is going to give a 0 or 2 doesn't matter, but we have to add all the second which can come from that particular path. And when we'll have a second update, you have already seen that either we have an apple or the child should have apple. So what we can do, we can check a condition. If has apple of that particular node, that means if that particular index is true, that means this particular vertex has an apple. If it is not the case, then check it either the child has an apple, and that will be told by t second variable. So we can say if t second is greater than 0, that means it has already been updated somewhere. If that is updated, that means that particular one was having any apple, right? So we can say if t second is greater than 0, that means that particular node has any child that has an apple. So if any of this condition true, that means we have to take that particular path. Okay. Or what we can do, we can say one condition and, that is node which is not equal to 0. You can see guys, in starting node, if that has an apple, then we can say we don't need to take any second because we are standing there only, so we can easily get that particular apple without wasting any single second. So if node is not equal to 0, then add 2 second, then we can say t second is going to be equal to 2 plus equal to 2. Otherwise don't add it, right? Fine. After that we can return our t second. So this is how we can do this. Now guys, let's quickly call this function. So I'm going to say get apple, and here I'm going to pass my initial node is 0. I'm going to start from 0 position, and this is visited set is going to be empty, so let's pass this empty set. All right guys, so this is going to return total second, so we can directly return this function as well, return get apple 0 set. I hope this code should not have any error. Let's try to run this. So you guys can see that my all the cases are passed, case 1, case 2 and case 3. Let's try to submit this code. And here we go guys, it's successfully accepted. I hope you understood this. If you still have any kind of doubt, you can ask me in the comment section. I'm always there to help you. And guys, if you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.